Alright there, so today we're going to be taking a look at parts of circles, and in particular we're going to be examining a nice result about the chords of a circle, which you can see at the top of the page here. It says that the intercepting arcs of congruent chords are congruent. Now if you're most people and you're not really an egghead like me, you gotta be asking yourself, what does half of this stuff mean? You know, like what is an intercepting arc? Well, you look at this diagram right here and you can see these two highlighted sections. These are intercepting arcs. Technically speaking, an intersecting arc is an arc who shares the same endpoints as a particular chord. But an easier way to think about it is to say, hey, it's the section of the circle that's kind of like cut off from the rest by the chord. Never mind the specifics though. If you see those little congruent hash marks somewhere on the curvy part of the circle, you know you got two congruent arcs. And today, that's the most important thing. Now, any type of problem we have that has anything to do with this particular result here is going to be one of two things. You're either going to have to find the value of a variable, or you're going to have to find the length of a chord. So here's the thing. The procedures are pretty much the same here. You start off by setting the two lengths equal to each other, and then solving for whatever variable is there. The distinction comes if you're trying to find the length of the arc itself. But the only extra thing you got to do there is take the value you found for your variable and plug into the expression for that particular arc. You'll see in the examples below. Alright, so I'm going to stop running my mouth and we're going to take a look at a couple problems. Alrighty, step 1, read the question. We want to solve for x here. Now I say this because you want to be careful. You don't want to do one thing when you got to do the other. If you're asked to solve for x, you don't want to go on and find the whole length of the entire chord. But if you're asked to find the length of the chord, you'd be bad if you just stopped at finding x. Listen to me, there's a lot of reasons for us to be able to complain in this world. Let's not be the source of our own pain and suffering, right? But I digress. The task here is to solve for x. Now before we can do that, we got to make sure that the intercepting arcs are the same length. And yep, here they are. Our arcs are congruent. This means the two chords are the same length. So, in order to figure out what x is, we set the two lengths equal to each other and solve like a normal linear equation, aka 6x minus 14 equals 16. Our first step here is to add 14 to both sides. We want to isolate that variable, and so we get 6x is equal to 30, and then we divide by the coefficient there to get the variable by itself. This gives us a final answer of x equals 5, and there you go. Alright, that was a problem for babies. Why don't we go ahead and take a look at a problem with the algebra that's a little tougher. Once again, we're going to go ahead and read the question first. We want to solve for x here. We check our intercepted arcs, and yep, they are congruent. So this means that we set the two arc lengths equal to each other and solve for x like normal, aka 7x minus 4 equals 2x plus 1. And then we solve like normal. We'll start by subtracting the smaller x over to the other side because that's going to make sure we have a positive coefficient in front of our x. This gives us 5x minus 4 is equal to 1. We add the 4 over because now we want to isolate our variable term to get it all by itself on its own side of the equals. This gives us 5x is equal to 5. And then we divide by 5 because we're trying to undo that multiplication. This gives us a final answer of x is equal to 1. And so ends that problem. Alright, I think we understand how to find x. Why don't we go ahead and take a look at a problem that asks us to find the length of the actual chord. They ask, and so shall you receive, right? Here we want to find the length of mn. Notice that there's no line over mn. That means we want the actual length of the chord. We see our intercepting arcs are congruent, so we start this problem the same as we did before. Take your two lengths, set them equal to each other, solve for x. This gives us 3x plus 7 equals 2x plus 19. And then we go on autopilot. Subtract the 2x from both sides. You're trying to take the small variable over to the big variable. This gives us 1x, or x plus 7 is equal to 19. You minus 7 from both sides to get your final value for x, which is, of course, x equals 12. Now remember, we're not done with this problem yet. We're going to figure out the length of mn. mn is expressed as 3x plus 7. So let's plug in 12 to 3x plus 7. The length of mn is equal to 3 times 12 plus 7. There we go, right? 3 times 12, of course, is 36 plus 7. That gives us a final answer of 43, and the length of mn is equal to 43. Got it? Alright, let's take a look at one more example here trying to do the same exact thing. So our last example again is asking us to find the length of a chord, specifically HK this time, which is here expressed as 3x minus 4. We check our intercepting arcs, they are congruent, and so we proceed as normal. Take your two equations, set them equal to each other. 5x minus 20 equals 3x minus 4. Now we solve for x. Take the small variable to the big variable, minus 3x from both sides. This gives us 2x minus 20 is equal to negative 4. Then we're going to add 20 to both sides, like so. This is going to give us 2x is equal to 16. And then we divide by 2, and that's going to help us solve for x. X, at the end of the day, is equal to 8. But again, we are not done. We wanted to find hk. Hk is expressed as 3x minus 4, so let's plug in 8 to x for 3x minus 4. Hk equals 3 times 8 minus 4. We evaluate. 3 times 8 is 24. Then we take away that 4 to give us the length of hk as 20. Excellent. And so that's everything. We've covered both topics pretty well by now. Now remember, all of our work here came from the very nice result that the intercepting arcs of congruent chords are congruent. Usually, though, when we're trying to do problems like this, we're not worried about the arcs themselves so much as how they inform on the chords. If the arcs are the same, then the chords have to be the same. This means the steps are pretty simple. You take your two lengths, you set them equal to each other, and you solve for x. If you need to find the actual length of the arc, then you're going to take that value for x, and you're going to plug it into the expression associated with the length of that arc. And that's it. Nothing to lose any sleep over. Hopefully you got something from this video, but feel free to watch it again anytime you need a little bit of a refresher. Hey, I'm leaving now. Take it easy.